In this question, we've been asked to sketch each of these curves showing the coordinates of any points of intersection with the coordinate axes. So just remember that a sketch is not a plot. We're not trying to find corresponding x and y values. We're really looking for the shape of the graph, the shape of the function, and some important points where it crosses the axis. So the first one that we're working with, y equals x squared minus 9. So this is a quadratic. And if we want to know the roots of this quadratic, if we want to know where it intersects with the y-axis, we can solve this quadratic equal to 0. When we do, we see that we can actually factorize. I've recognized the difference of two squares. So x plus 3, x minus 3 are the brackets I would get. From here, I can get two solutions. X equals 3, x equals negative 3. If you hadn't seen the difference of two squares and you just rearranged to get x squared equals 9 and then x equals square root of 9, we would need to consider both the positive and negative square root. This way it's laid out in front of us that both of these brackets are going to lead to their own distinct solution. Okay, so now that we know where it crosses the x-axis, we have one more intercept to consider, which is where it crosses the y-axis. Just looking at the graph, the function itself, we can see the y-intercept by inspection. The constant term in any quadratic is always going to be the y-intercept. It's the value of y when x equals 0. Now that we have these three, we just need the correct segment of the coordinate grid and we can plot. So 3, negative 3, negative 9. This is a positive quadratic. We can sketch through there. If we weren't sure from the position of these 3 points, we can always look back to the quadratic, and since the coefficient of x squared is positive, we know this will be a positive quadratic. Okay, on to the next one. Y equals x squared minus 2x. So once again, if we solve equal to 0, we can find the x-intercepts. We can find the roots of this equation. When I factorize, I get x and x minus 2, which leads to results x equals 0 and x equals positive 2. One more to find is the y-intercept. Well, as I've said before, we look to the equation, we look to the quadratic equation, and we want to find the constant term. So by inspection, we can see what the constant term is. Here, there is no constant term. Nothing's been written down, which means when x equals 0, y is going to equal 0. The y-intercept is y equals 0. So let's get our coordinates grid and plot these 3 points. And just be an alert that when we plot them, although we found 3, there's only 2 things to plot, because the x-intercept x equals 0 by definition has a y-coordinate of 0. And the y-intercept y equals 0 by definition has an x-coordinate of 0. These two are actually referring to the same point, 0 and 2. So there's not enough just from these coordinate intercepts to know if we have a positive or negative curve to sketch. We're looking to the equation. The coefficient of x squared is positive, it's positive 1, so we know we have a positive quadratic curve that we should be sketching. So whenever you're asked to sketch a curve, we're looking to find the x-intercepts and the y-intercepts.